What's going on, guys? Welcome to the next video on C++. We left off last time by writing C out. We explained include header IO stream. Then we used using namespace std, then int main and C out, and then again C out, and then return 0, and we close our block or parentheses. All right, so today we're going to discuss what happens when we run our program. We build and run, and when the program fires up, what happens inside the system. As a C++ programmer, you guys should be aware, at least have some basic knowledge what happens inside the hardware, underneath the assembly language or execution files, what happens inside this hardware, because C++ is very close to the hardware. See if with the C++ you guys can build applications like Microsoft operating systems or Apple or any other operating system, and operating systems very close to the hardware of the computer. Okay, so before that we go through that, we go and explore what was the first computers. All right, so I've got the thing here. The first computers was called ENIAC. It's electronic numerical integrator and computer. All right, so this was the first programmable electronic general purpose digital computer. Now I've got some photos. See, as you guys can see, the first computers, that's the first computers. The guy is standing here, all these programmers, and they're flipping these zeros and ones. As you can see, it's taking the entire room. So, and you guys can see the guy is working and they're flipping zeros and ones, because at the first computer, inside the computers only know zeros and ones. They've got no idea what this means, or this photo, or anything. Whatever is you do inside the computer is all streams of zeros and ones. That's all computer knows. So this is the, then again, you guys, that's the programmers, and that's how it looks like. So this was the first programmable computer. So, and it was called ENIAC. Yeah, you can see these photos. All right, so I'll go back, and this is in Wikipedia. If you guys want to go and explore, that's the URL about the wiki ENIAC. And you guys, if you want to read, University of Pennsylvania in February 15, 1946. Okay, so that's the story of the first computers. You guys can see that's all zeros and one. As a C++ programmer, you guys should be aware at least about 0 and 1 ones, stream of 0 and 1 binaries. What happens when you press this run, build and run, and fires up the computer? What happens inside the system? All right, so I've made a slide here. So what we do is that when we go in our IDE, that's our source file, that's our what we're writing here, our text file, whatever you call it. Okay, so when we go here, that's our editor. This is the editor, whatever you can see on the screen. All right, so that's our source file, and this is our source file. Whatever you can see, include IO stream, header, namespace, int main. That's our source file, and that's extension. Extension is CPP, C++, and CC. Sometimes you guys might see CC as well, but normally C++. The extension is very, very important, guys, because the computer need to know is it C extension or C++. Is it Python, PY, or Java? You can say Java. All right, that's our source file, and this source file, when it's before they use compiler, it includes the header file, and you guys can see the header file here. It's this header files inside this C++ library, but you guys can include your own. Say you guys can include. All right, so I made a mistake here, sorry about that. Okay, my own file .h, and you guys must you guys need to put this h. I put this h, but when you if you want to create your own thing in your project, in your own file, you guys should include like this. So it includes the files and libraries which are included inside the C++, and you can include your own. Say if you got like 10 other files, you can only include here. So you can use, like, for example, you can use like C++ library like mate. You can use stack. You can use other libraries which we're gonna go through in future videos. So now that's our file, our own file. That's a C++ system file. And when we fire up this compiler, the compiles. So the compiler, it translates the high level description into machine instruction for a particular processor. All right. So if you got a processor, it translates the higher level description into machine instruction for a particular processor. And as we discussed before, that C++ is a compiled language. So for a program to run, its source text has to be processed by compiler, producing object file, which is combined by linker yielding to executable program. So that's the object file. So the object file inside this thing is main. Our program becomes main CPP becomes main.obj object file. So when once we compile it, we press this fire up, it goes then becomes the obj file inside the computer. It becomes object file, and from there all other standard libraries and other libraries gets included to the linker, and it fires up and it goes to the inside the engine of our hardware, our program, our you can call it operating system, and it becomes a main.exe. It fires up. So say if you got a Windows or any other programs, you guys see this exe all the time. So this exe is an executable file, and it starts running and becomes a machine code, so that our computer understand what we mean. And as you guys, just to go briefly for this C++, this C++ interacts directly with the hardware. So for the hardware, you guys need to know this stack. In the future lessons, we go through this stack. What is stack? The stack is a conceptual area of main memory RAM, random access memory, which is designated by the operating system when the program is started. So we need to know this stack, because C++ is very, very important for you guys to know that what happens under the hood, what happens when the program, when we fire up this thing. Say I fire up, it runs. Okay, so it's telling me that there's no such thing as this, which is not. That's for okay. So I'll build and run again. As you guys can see, that's fire up. Now our operating system translate this into the executable file, and it's showing on the console, which is this one. This one's telling that, instructing this C++ to see out of this one and show it on the console what we wrote here. Okay. So the process, this is the same process as this. We included our header file. That's our main.cpp. That's our main.cpp file. Okay, that's our source file, main CPP. We included the header files. Okay, so that's our header files here. That's a header part of this CPP. And what we use, the namespace. Namespace is just to go briefly for the namespace. It tells the compiler to standard namespace. Namespace are a mechanism for avoiding naming conflict for large programs. So if you got a large programs, and you guys should need to use this namespace. When we go further inside C++, I'm gonna explain this in depth, what is namespace is. So namespace is very useful. In C#, we use namespace. In PHP, we use namespace. In almost all programming languages, we use namespace to avoid this naming conflicts between the programs or programs and files. All right, so we go here and we see this one. Okay, we're at the stack. A stack is a conceptual area of main memory, okay, RAM, which is designated by operating system when the program is started. Different operating system starts at the different addresses at convention. Okay, so a stack, so I'll put it there. This is very, very important. I'll just go briefly with you guys because you guys needs to know stack, because in a future videos we're going to go through in depth into the stack. A stack is like a stack, just to go briefly, a stack is like a stack of plates, or a stack of pallets, or a stack of whatever is you can pile on each other, on top of each other. That's a stack. So so the stack is, okay, the stack is a conceptual area of main memory RAM, which I explained to you guys before. All right, so the stack is LIFO and FILO. LIFO and FILO. So what is LIFO? LIFO is last in first out. So when you guys put a plate on top of the stack, it's last in, and you guys take it, it's first out. So this one is opposite, first in, last out. So it goes to the first in and it goes to the last out. Okay, so any stack, how we do that, how we put it last in, how we put it in, and first out, how we do this. Like I mentioned, you guys, if you guys want to put a plate, you put it with your hand, yeah, or with a machine or something. You guys looking that if I'm putting plates on top of each other, it goes all the way up. So with what about inside the computer? You guys can't put with the hand inside the computer RAM, yeah, or inside the stack. So we do use the command is push function, and inside the push function, data is added on top of stack. Sorry guys, stack. Okay, so how we remove that? So if a push function, if you guys done assembly language, you know what I'm talking about. So if what is the opposite, like how we take the data off? So it's called pop. It's not a pop music or anything, but just a pop function. Data is removed off the top, is removed. I know it's a little bit scary guys, but trust me, you'll need this in future lessons. And we've got the third one, and the last one is peak. And peak examines the top element in the stack. Okay, so as a C++ programmer, I'm not sure if you guys know, but it's very, very important, very extremely important that you guys should be aware, or at least have a little basic knowledge of this stack, how the stack works, how this LIFO and FILO works, and this push and pop and peak functions. This is all functions inside this assembly language, but you guys can use, because as I explained to you guys before, that this was the first computer, and the first computer they're using the 0, 0 and 1 ones, they're flipping up and down, and someone along the line came in and invented this assembly language. Assembly language deals with 0, 0 and 1 ones, and it's embedded inside this hardware. And then another guy came in and invented this C. With the C, it makes the life a lot easier, the job a lot easier, because you don't need to do this 0, 0 and 1 ones, or this assembly language. Then we had this C++, which makes it a lot easier. So C++ is also including all the functionalities of C. So just to be, and plus it adds its own object-oriented programming, or classes. So it's got a procedural programming and object-oriented programming. Okay, so we explored this push, pop, and pick the stack, and what happens inside under the hood when the program runs. Alright guys, that's it for now. Thanks for watching. I'll see you guys in the next video. Bye.